right here. What could you do with vector v? You could take vector v, you could paste it right, no, that's not what I wanted. Great, now you get the last class's copy and paste. What can we do with this? We could take this and go rotate. Let's go rotate right 90 degrees. Let's go rotate right 90 degrees. So what is that vector now? What does that vector represent? Negative of what? Negative v, right? So you can still use the same rule, tip to tail, add it to w, and what do you end up with? Well, you end up with w minus v, and that's in this definition x, right there. It's the same vector. It's the same vector. Just another way to look at it. Another way to look at it. Okay, what's the commonality between these three vectors, or these four vectors? What do they have in common? Here, do. What does that 2 do? Magnitude by 2. Does it change the direction? No. It's the same sign as the original coefficient, so it doesn't change the direction. It just doubles the magnitude. This halves it, and then what does the negative 2 do? Flips it around, makes it go backwards. Exciting. Very exciting. The 0 vector is just a point. Nice. Very nice. Now, this is a lot of text just to say that you get to use the character lambda now. Yay, how many people have used lambda before? Yeah, lambda's all over the place, everybody. Lambda's all over the place. Lambda is what you're going to see. So if you have lambda and times a vector v, what could the magnitude of vector v be? What could the magnitude be?
0.
Anything. 0, 1, 2, 12, 50, right? Could be anything, right? If lambda is a scalar, what does a scalar times a vector do to the magnitude? Well, let's say the magnitude of vector v is 2. So let's say the magnitude of vector v, just for example, is 2. What happens if you multiplied it by 5? What happens? It's 10 all of a sudden, right? You just multiply the magnitude times the lambda value. What happens if the vector value, what happens if the magnitude of v is 1? It'd be called a unit vector, and it would just be, if lambda was 5, the new magnitude would be 5, right? If you multiply, if lambda is negative, what does it do to the vector? It turns it around. Exciting.
What do you need to ask?
So that's a good thing to ask. Well, thank you, Nam. This means magnitude. Magnitude. So what does that mean in terms of a vector? So let's say vector v, let's just give you an example. Vector v was vector 2, 5. If I asked you for the magnitude of 2, 5, anybody know how to do that? What would that be? Square root of 2 squared plus 5 squared. It's just the length of that vector. That's it. That's all it means. The double bars means magnitude of a vector. Here's the cool thing we get to exist in, though. We get to exist in this space right here. Da, 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 da. Unit vectors. They're all unit vectors, right? They're all magnitude of 1. Now, when you are given the choice to arbitrarily choose which vectors to use, generally speaking, what numbers are generally easier to work with? The number 1 is generally easy to work with. The number 0 sometimes, but it can cause problems. The point is, we will get to choose what vector to use sometimes. And in general, magnitude 1 is going to be super freaking helpful. Super helpful. So for example, what's this? Oh wait, before we do that one, let's do this right here. So example 3, decide whether the vector 2, 3, 5 is parallel to each of the following. Is it parallel to all of those? Poor notation. I totally agree that this is poor notation because u's and v's look the same. Magnitude is a scalar. So when you divide a vector by a scalar, what do you get? If you divide a vector by a scalar, you still have a vector, right? So these are two vectors. So what can you tell me about u? What does u represent? It represents what type of vector? A unit vector. If you divide a vector by its magnitude, what is the magnitude of the vector going to become? 1. Exactly. Exactly. So this is how you turn any vector into a unit vector going in the same direction. You divide it by its magnitude, which is a scalar number, a magnitude. You're going to do this a bunch because, remember, dealing with unit vectors, way nicer than dealing with all the other vectors. Sometimes you're going to have to, but when you have the chance, you're going to I want to say unify, but that is not it. So for example, this vector right here, v, I could ask you, if this is the vector v, what is the unit vector that goes in the same direction? And you have two ways of answering that. Two forms. You can answer it in component form. You could also answer it in something I plus something j, where they are the same numbers here. This number is the same as this number, and this number is the same as this number. By yourself, everybody, see if you can figure out what those numbers are. By yourself. Don't say anything here. No, because the magnitude of v, of this thing right here, is going to be 1 squared plus 3, so square root of 10. So if you want to turn it into a unit vector, what do you have to divide by? Square root of 10, that's it. You just have to divide by the square root of 10. So does this vector, is that a unit vector? Yeah. This squared plus this squared is 1. The square root of 1 is 1. Super exciting. So now you just get to do some relatively straightforward arithmetic for homework. Does that sound good? Some relatively straightforward work for homework? Yeah. Sounds pretty good?